All right, so happy to be here today. I'm going to talk to you guys about serverless architecture, and I hope that by the end of this talk, you'll have ideas of how to potentially use it in your upcoming projects and have a better understanding of what serverless is. To start, I'm going to give a little bit of background about myself. So I'm a husband and a father. I have a beautiful 1.5-year-old daughter and a son in a couple of weeks. Hopefully my wife doesn't call me right now because she's about to give birth. I'm also an engineer, as you might have guessed. I started my career at IBM as a software engineer for performance testing in the big data division, primarily focused on on-premises applications. I later on moved on to become a full-stack developer, working at Flipp under the coupons team. Also, I've been very interested in the crypto space for the last several years, which led me to my next role at Coinsquare, where I helped build the back-end system that communicates between the front end and blockchain. Now, over the last 7-8 months, I've had the opportunity to co-found a company with two of my good friends called Moregidge. I'll tell you a little bit more about it. So what is Moregidge? I'm going to make an assumption that some of you here today have gone through a mortgage process. It is awful, it sucks, it's long, there's a lot of paperwork, you don't know what's going on up until the end, you hope you get the house. And that's why we kind of went ahead and built Moregidge. The real estate and mortgage space lacks innovation, and it was time to change. So Moregidge is a digital platform that simplifies the mortgage transaction. When we built it out, we predicated it on 3 different things. One, it had to be an intuitive platform. And what I mean by that is, not only does it have to look good, but it also has to be seamless and easy to use. So you're up and running under 5 minutes. Number 2, it had to be fully integrated. The mortgage transaction involves a lot of data, so you have to make sure that with a click of a button, you have access to all that data. And finally, transparency. There's a lot of people that collaborate on the mortgage application, so we need to be able to make sure that everybody's aware. A client that's getting a mortgage know what's going on, similarly with the real estate agent, mortgage agent, etc. So with that being said, as you can imagine, we deal with a ton of sensitive data, SIN numbers, your employment history, your address. So when we thought out how to build the platform, security was at top of mind. For background, and for the remaining of the slides, we'll be referencing AWS. We're fully built in AWS for a couple reasons. One, we're familiar with it. Number 2, the amount of services that they provide and how easy they integrate with one another makes it that much easier to build up. So with that background, I'll jump into what serverless computing is. So by definition, it's a cloud computing execution model where the cloud providers run the servers and manage them for you, and the allocation of machine resources, essentially eliminating any IT infrastructure. So if you think about it, imagine there's a server in the cloud that all you had to do, you didn't have to set it up, all you had to do was write code, deploy it, and it executes. Now imagine you had to do it at a larger scale. You had to do, based on your needs, you had to do 50, 200, etc. That still exists, and you had to do zero work. All you had to do is write your code, and the rest is done by the cloud provider. So you don't have to worry about infrastructure, scaling up or down, etc. And the service that provides us with this, that I'll be referencing again throughout the slides, is AWS Lambda. It's the service that allows you to write code, that gives you the capability of deploying your code to and executing it without doing much work. So, now that you have a better understanding of what serverless is, we have 5 key reasons why we personally believe that you should use serverless, why we do use serverless. And the first one, going back to what I said, we deal with a ton of private data. So number 1 is security. And with security, we have 3 core components part of that make up that security. Number 1 is each execution runs in isolation, so there's no overlap between another. Number 2, granular level permissions. So given that you write functions, per se, each one has the separation of responsibility. So you would assign the permissions needed for that specific Lambda, in this case, to access the data it needs, nothing else. And finally, there's no service SSH2. So we recently went through an Equifax audit several months ago, and it was an interesting process because I don't think I believe they said that they've not done an audit with a company that's been pure serverless like we have. We spent about 2 hours educating them what serverless is because they wanted to find out how to SSH into a server. We told them we can't, and we kept going back and forth for 2 hours. Number 2 is cost efficiency. So as a startup, we started the company about 7 to 8 months ago. We didn't have a lot of money to spend. So what serverless allows you to do is you never pay for idle time, you just pay for execution, and that's it. There's no infrastructure to manage, as I mentioned. Everything is in the cloud, ready, set up for you, will scale up and down. All you have to do is write your code that will execute. And this allows us to do quick start. So we're able to deploy code really quickly, and there's multi-language support. So at Moregidge, we use Java, we use TypeScript and JavaScript. And with all those benefits in mind, there's little overhead. So we are able to run our platform with skeleton crew, basically. Now, before I jump into how to use serverless, I broke it down into the building blocks. Think of them as Lego. So these are the different components that we assemble together to be able to build a small ecosystem or a service. Lambda being at the compute level, it is what provides serverless, and additionally these services that work with Lambda. I'm not going to go into detail each one, but I will be when I go through the use cases upcoming. And there's 6 use cases that I'd like to cover today, all of which we use at Moregidge that serverless can make easier and better. Number 1 is APIs. You're all familiar with that, building RESTful APIs. How can I serve data and consume data? Number 2 is A/B testing, something that a lot of companies do when releasing major features. Event-driven architecture, scheduled jobs, bulk jobs such as like data aggregation analytics, and finally, the website, which is the entirety of our platform. So jumping into the first example. So the building blocks required to create an API is actually pretty straightforward. All you need is the API gateway and a Lambda. And in this case, referencing back to Moregidge, we have 2 use cases for exposing APIs and building them. One is to provide the APIs and the data to our platform, and number 2 is for our partners. Our partners need to be able to send us data, they need to be able to consume data. So in this simple example, think about it where I create my routes, my RESTful APIs routes in API gateway, and then I connect the routes that are dedicated to our platform to the Lambda number 1, and the routes dedicated to partners to Lambda number 2. With going back to granular level permissions, we've isolated each Lambda such that it only has access to the data that it needs. So there will be no overlap. A partner's Lambda that executes cannot have access to the same level of data that the other Lambda has access to. Event-driven. So we do a ton of event-driven executions, and one of the examples is emails. So our mortgage brokers and agents use our platform as a CRM. And one of the ways they use it is they communicate with their clients, the person that is seeking a mortgage. There's 2 ways to go about that. 101, as if you're sending through your Gmail app, and number 2, through email marketing. So for example, doing blast 1,000 emails. But in both those scenarios, they need to be able to store all the data that is associated with an email. That means if it was opened, links clicked, marked as spam, etc. And the building blocks required for that is we use SES, which is the email service that Amazon provides to just send emails, SNS, which acts as a pub/sub to be able to send messages through, and Lambda to connect to. RDS is our database. So what happens is when an email gets fired, we embed a piece of code in it, and when that code or that event occurs, it notifies SES, which in turn publishes a message to SNS. And the reason there's 2 Lambdas here is because one is exposed to the outside world, where it will consume the message from SNS and modify the data however it needs. And then the second one is protected behind, not exposed to the outside world, where it will consume that updated message, persist it to the database. Schedule jobs. So we have a ton of schedule jobs. That's something as simple as reminders, follow-ups, even thumbnail generation. So when we do email marketing, when somebody updates, a client updates their email template, we need to be able to generate the thumbnail so it gets displayed on the front end. And one way to go about it is using CloudWatch. So CloudWatch is typically used for logging, but they also have the ability to do timed jobs using cron expressions. And when clients set up reminders, we need to make sure that they get the alert at 8 a.m. the day off, as well as 10 minutes before, similar to how your Google Calendar works. It's pretty straightforward. We just set up the cron expression, trigger the Lambda, and during those time frames, we execute on the data we have. So A/B testing. This one is actually one of my favorite ones, only because we set it up in about 10 minutes. So we do a ton of feature releases, and as a startup, a lot of them involve changing the front end drastically. And before we do that, we need to make sure that it resonates with our clients. So the way we set that up is our front end is also serverless. So it's statically hosted on S3. We use CloudFront as our CDN to serve it to our clients. And all we have to do is attach something called Lambda at Edge into that CloudFront. With simple logic, you can do that with maybe 2 lines of code, like a coin flip. If they get heads, show them the website from S3. If they get tails, show them the website from the bottom S3. And therefore, you can run A/B tests and collect the metrics that you need. All right, so bulk jobs. That's actually one of my other interesting ones, where we run a ton of bulk jobs. One for data aggregation and collection. So we deal with a ton of data. So like, for example, interest rates. We need to make sure that those data are up to date. So we go out and fetch them periodically, maybe once or twice every minute. But the second example for it is automated front-end testing. So traditionally, the way we built it is set up an EC2 instance, deploy a couple of frameworks, and manage a queue of test cases, let's say in this case 500. What we were able to achieve with serverless is, in parallel, execute 500 test cases all at once, and the results come back within a minute at a cost that is insanely cheap. The only issue around it is Lambda has limitations, which I'll touch upon later, that requires us to put our headless browser, our Chromium instance in S3 and fetch it on execution due to how big it is. It's 200 megabytes. It adds only a couple hundred milliseconds latency, but it's not bad. So for perspective, on the free tier, we do about, like I said, 500 requests. They take about 30 seconds. We do once a day. That's about 25,000 requests a month. We end up paying 86 cents a month versus what we had traditionally, which was 138. So it's 138 times better than doing it the usual way. Plus, you don't have to manage queuing. And the final example is our serverless website. So this is a more involved use case, but this is the entirety of our CRM system. Like I said, the front end is statically hosted and it's serverless as well. So we render through the front end. The back end as well right there is, as I said, serverless too. The only way to communicate with one another is through API gateway. Additionally here, even though there's a lot of security that is added to Lambda out of the box, we added a VPC layer on top, so it's inaccessible to the outside world. That just adds another layer of peace of mind so that we don't have to worry about data being exposed. So what does this cost? What does this look like for us? And these are actual monthly bills for them. So we compared it to what we had set up with an EC2 instance. We, like I said, do a typical day, a typical minute, we do over 550 live executions. That's API requests or bulk jobs, scheduled jobs, whatever it may be. So that's about 24 million executions a month. That amounts to 416 in terms of requests. They're broken down by request and compute. And by compute, we use a gig of memory per each. The average comes out to be 700 milliseconds. So all in all, we end up paying just under $300 versus the alternative of almost $1,100. So to summarize, this is what I think serverless is. You just write code, zip it up, upload it, and it runs. There's no infrastructure, nothing to manage, no need for a DevOps team, etc. So with that in mind, from a limitations perspective, there are limitations with serverless that have existed majority of the life of serverless. And the three key ones are deployment, cold start, and monitoring. From a deployment perspective, like I said, there's a 15 megabyte limit, at least in AWS. I believe Azure is unlimited, but you have to pay for storage, and Google is 100 megabytes. But running our the bulk jobs front-end testing, we had to get creative, put the Chromium in S3, and then fetch it only on execution. So we found ways around that. Additionally, we do tree shaking, so we get rid of unused code and node packages. Given that we're Node, as some of you might know, node packages can blow up. So we get rid of code that is not used. As well as the other issue is coordinated deploy for services. So some Lambdas expect the other Lambdas that they have to communicate with to have the latest code. So the way we go about that is we deploy certain stages and then flip the switch once the stages are up. From a cold start perspective, that's the most common limitation that everybody knows about. Because there's no instance that is always up, it takes time to boot up. And in our case, additionally, because we're behind a VPC and ENI has to boot up to give it access to outside world, limited access to outside world, that can add to a couple of seconds. And the only way, unfortunately, to go about it right now is to periodically ping the high or your most important Lambdas to keep some containers up. And finally, monitoring. So at Moregidge, we have over 65 Lambdas. And keeping track of all of them from a monitoring perspective can be very complicated. So what we do is we created our own Lambda that goes and grabs the output of all the additional Lambdas, aggregates them, cleans up unnecessary noise, and when we use that. So what's next for us in terms of serverless? So we're looking at three things over the next couple of months, most of which are recent. So we're looking at cross-service integration, and primarily for front-end testing. And the reason being is we don't have to, if we use Google Cloud, we won't have to worry about fetching from an object storage the Chromium instance. It will be bundled up in the package. Number two is AWS Firecracker. That was open source several months ago. It's the underlying technology that right now powers Lambda. It's a kernel-based VM that is heavily optimized for serverless. So we're trying to see if there's any internal use cases for it. And the last thing is WebSockets. So API Gateway added the capability of doing WebSockets several months ago. We're exploring using it for certain features of our website, but keeping in mind that cold start is still an issue with WebSockets. And that's it. Any questions?
Just wondering if you're doing cloud formations directly, or if you're using SLS or something.
Yeah, so we've had experience with CloudFormation. We partially used it. It had some issues that we had where our integration between the API Gateway and the Lambda requires what they call a proxy integration. And they've had a couple of bugs in the past where it accidentally or unintentionally removes that feature. So we're working through the kinks with AWS through that, but primarily at CloudFormation.
What do you use to authenticate with partners?
Yeah, so I'll go back to the building blocks. We use Cognito. Yeah. So what we try to do is warehouse everything in AWS, use the services they provide because they integrate together very seamlessly. So Cognito allows us to authenticate and also authorize additional on top of it. So we expose API inputs to them, but we have to make sure that they're the right person that has access to them.
So from the business side, you're not like a kayak, you're not an aggregator of rates. Do you partner directly with the mortgage lenders, or like are you pulling from their back end, or what? How does that work? So as a user, I go in and I say, give me a good rate. How does that work?
So we're not a consumer-facing platform. We're primarily built for mortgage brokers and agents that will facilitate the transaction to you. We do have a consumer side where you would log in and view the whole process of your mortgage transaction, end-to-end, where you'd upload your document, fill, sign everything on it. But we're not a rate comparison like Rate.co, for example.
Gotcha. From a security standpoint, is it built into your code or into AWS? The restrictions between being able to see the data?
Both. So we heavily utilize the AWS capability of doing granular level permissions. Yeah. So to give you perspective, like going back to this slide, in the backend here we have access to either DynamoDB for document-based storage, or we have access to RDS, both of which these lambdas either have access to specific tables in Dynamo, similarly have specific access to tables in RDS. So those permissions are very granular that they can only access what they need. Additionally, we do have application layer validations on top of it.
Given that you don't have local machinery, what's the most difficult part about developing and debugging serverless?
Yeah, so we don't have, like, say, local machines. So there's no, like, as opposed to building like a simple Node app in Express or Co that you can boot up and test. We have a bunch of different ways. One of which we ensure that every person has their own environment in the cloud that they can use to test on. Additionally, we just have a small framework that we built in-house that allows you to execute specific routes as if they were invoked externally.
I'm just curious. It sounds like you, at one point, you weren't serverless and then you became serverless. What was the rollout like? At least with regards to your dev team, was there feedback, was there tough lessons to learn?
So we primarily went directly into serverless, and that's out of experience. I've worked on microservices in the past for actually majority of my years. But the price you see is we had to spin up in the early days, like 7-8 months ago, we had to spin up both of them to evaluate from a cost perspective, because as a startup, we had to make sure that we don't spend too much. And from a security perspective, given the level of data we deal with, we had to make sure that benefit is higher for us.
So what frameworks do you use?
Yeah, so we don't use any frameworks that are available publicly. We're looking at open sourcing some of the ones we do use. They're all built in-house. And I think that's part of the struggle of serverless as a whole in the industry, is that there's no educational aspect behind it. It's not like where you can download boilerplate code. There are some frameworks that exist, but it's not like the traditional download like a Node boilerplate or Ruby, Unreal, etc., and write your code and execute it. When people set up a Lambda, they think they just can write code, but they don't know what to write as well. So there's an educational piece behind it, and we're trying to find ways to make it easier for people to adopt, and that's partially where the use cases come from. And we will be open sourcing some of the frameworks that we've built in-house.
So when you were talking about cold starts with lambdas, eventually you have to kind of every couple of minutes ping them to make sure they stay up. What do you mean by ping them? You just actually invoke the lambdas, tell it to skip all the code?
Yeah, so what we do is, in this example, we use CloudWatch to trigger certain lambdas. Out of the 65, there's only 4 that are critical to the business to be up every now and then. Essentially, render serverless useless per se is like having an EC2 instance that is up. But for us, that's still beneficial to use serverless given the security that is added on top. But what we do is periodically, like let's say every 30 seconds, we invoke it basically as like a ping. And it keeps a couple of containers up, depending on how many we need.
What does that do to your cost? Is there a significant difference?
No. So if you look at going back to
Versus if you do it and if you don't do it.
yeah, for sure. So if you look at how many requests you could do a month on the free tier, and again, the tiers that AWS provides is actually very enticing, that they're not that expensive. You get 1 million requests a month, like in Vokes, and a ping, you get about 136,000 seconds a month. A ping typically takes maybe 100 milliseconds. The cost per 1 million is about 20 cents. So in terms of cost for us, it's actually negligible.
Sorry, another question. I also noticed in one of your diagrams that you also had your RDS right into Dynamo.
No. So Dynamo is outside. We didn't put Dynamo in a VPC. It just communicates with everything behind the VPC. In this case, Lambda. So Lambda communicates with Dynamo. Similarly, API Gateway communicates with Lambda, and just the Lambdas communicate with RDS alone.
Out of curiosity, what goes into that Dynamo?
What?
Just out of curiosity, what goes into that Dynamo?
Oh, so we have some of our the way we persist some of our data. It's better for performance to use a document store. Yeah, it's unstructured data, structured, unstructured, partially. Yeah.
You say you have lambdas to keep track of your lambdas. How does that work exactly?
Okay, so I don't remember where that was. Oh, the monitoring, right? So we have a Lambda that goes in, so we spit out all the logs that come out of CloudWatch into Elasticsearch, and we have a Lambda that goes in and filters through all unnecessary noise. In this case, for example, ping, that's unnecessary noise that we don't need. It aggregates the logs across different Lambdas. We have our own internal logger that we built to make it easier, which is another thing we're looking to open source, because logging with serverless can be very complicated. It's across different instances, and if you have different Lambdas, you want to be able to trace through it. So we have a custom logger that helps us, after aggregating all those stuff, it spits out into one stream. So every Lambda has its own stream, or log group per se. We have to look at only one log group to see the whole picture of 65 Lambdas.
You mentioned cleaning up your code.
Tree shaking?
Yeah, I forget why you said that. But how often do you do that?
That's part of the deploy process. So we have a custom deploy process that parses through the entire code base and gets rid of code in node packages that are not needed, because there's a lot of noise in node packages, and they're huge. You can go into a couple hundred megs. So those utilities in those packages, let's say you download a package like Lodash that has thousands of functionalities and you only use 2, we end up throwing away the 998.
So if you to control how much computation you actually do, what's stopping someone from saying just DDoSing your server and you end up paying millions?
Yeah, so one of the building blocks here that I did not show is we use AWS WAF to fully protect us. So it's the added capability to connect that to Lambda that protects against DDoS, injections, etc. So it's a service that is provided by AWS, and I think the cost for us is about $20 a month.
What are some applications which don't really cater to serverless, or do you believe all applications generally do?
I don't. It's kind of tough to say what ones should fit that I didn't put in the use case. You kind of have to try it out to see if it fits. I believe that potentially down the line, maybe 5-10 years, as this evolves, because it's still, I consider it in its infancy, serverless, that it will be the new programming paradigm. It requires a different mindset of when developing, as opposed to, like I said, downloading a node boilerplate, which traditionally what people do. Also, the community, as it's growing, there's a lot of things that have been fixed, figured out, and that gives us a clearer picture down the line. But the use cases I displayed today is the ones we use, which I think fit maybe to 60-70% of today's web apps that exist in the market.
Thank you, Adam.